Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. The National Electrical Code, or NEC, addresses GFCI protection requirements. According to the NEC, a GFCI can protect an unlimited number of downstream receptacles on the load side. This means that one GFCI device can provide ground fault protection for multiple electrical outlets connected after it in the circuit. The key limitation is that the total load connected to all the protected receptacles must not exceed the GFCI's rated amperage. For example, if a GFCI is rated for 20 amps, the combined load of all devices plugged into the downstream receptacle should not exceed 20 amps. However, it's crucial to understand that local electrical codes may have more restrictive requirements than the NEC. Some jurisdictions may impose limits on the number of receptacles that can be protected by a single GFCI, regardless of the total load. This is where variations in local amendments to the NEC or specific local electrical ordinances can come into play. In addition to local codes, manufacturers of GFCI devices may also have their own specifications or recommendations regarding the number of downstream receptacles that can be protected. These specifications are typically outlined in the product's installation instructions or technical documentation. It's essential to review these documents carefully to ensure compliance with the manufacturer's guidelines. Therefore, while the NEC permits an unlimited number of downstream receptacles, it's imperative to verify local codes and manufacturer specifications to determine any restrictions. Ignoring these factors could result in code violations or improper operation of the GFCI device. To ensure compliance and safety, follow these steps. Firstly, consult the local electrical code. Contact the local authority having jurisdiction, or OJ, such as the city or county building department, to obtain a copy of the local electrical code. Review the code sections related to GFCI protection to identify any specific requirements or limitations on the number of downstream receptacles. Secondly, review manufacturer specifications. Obtain the installation instructions and technical documentation for the specific GFCI device being used. Carefully review the manufacturer's specifications regarding the number of downstream receptacles that can be protected. Thirdly, calculate the total load. Determine the total amperage of all devices that will be connected to the downstream receptacles. Ensure that the total load does not exceed the GFCI's rated amperage. Fourthly, consider practical considerations. Even if the local code and manufacturer specifications allow an unlimited number of downstream receptacles, consider the practical implications of such a design. A large number of receptacles on a single GFCI may increase the likelihood of nuisance tripping if multiple devices draw current simultaneously. Fifthly, implement proper wiring practices. Ensure that all wiring connections are made correctly and that the wiring is properly sized for the load. Use appropriate wiring methods and materials to prevent electrical hazards. Sixthly, perform testing. After installation, test the GFCI device to verify that it is functioning properly. Use a GFCI tester to simulate a ground fault and ensure that the GFCI trips as intended. Seventhly, document the installation. Maintain records of the GFCI installation, including the date of installation, the location of the GFCI, and the number of downstream receptacles protected. This documentation can be helpful for future reference or inspections. Here are some additional factors to consider when determining the number of downstream receptacles for GFCI protection. Firstly, the type of occupancy. The type of occupancy, such as residential, commercial, or industrial, may influence the requirements for GFCI protection. Certain occupancies may have more stringent requirements than others. Secondly, the location of the receptacles. The location of the receptacles, such as bathrooms, kitchens, or outdoor areas, may also affect the requirements for GFCI protection. Receptacles in wet or damp locations typically require GFCI protection. Thirdly, the potential for ground faults. The potential for ground faults in the area served by the receptacle should be considered. Areas with a high potential for ground faults may require additional GFCI protection. Fourthly, the sensitivity of the equipment. The sensitivity of the equipment connected to the receptacle should also be taken into account. Sensitive electronic equipment may be more susceptible to damage from ground faults and may require additional protection. In summary, while the NEC allows an unlimited number of downstream receptacles to be protected by a single GFCI, it is essential to verify local codes and manufacturer specifications to determine any restrictions. Consider practical considerations, implement proper wiring practices, and perform testing to ensure compliance and safety. Remember that electrical codes and regulations are subject to change, so it's important to stay up to date on the latest requirement. Consult with a qualified electrical contractor or inspector if you have any questions or concerns regarding GFCI protection. Now let's talk more in depth about ground fault circuit interrupters. A ground fault circuit interrupter is an important safety device designed to protect people from electrical shock. It works by monitoring the current flowing in a circuit and quickly interrupting the power if it detects a ground fault. A ground fault occurs when electricity takes an unintended path to ground, such as through a person's body. This can happen if someone touches a live wire or if there is a fault in an electrical appliance. When a GFCI detects a ground fault, it trips the circuit and cuts off the power in a fraction of a second. This quick response can prevent serious injury or even death. GFCIs are commonly used in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. They are also required by electrical codes in many locations. How does a GFCI work? A GFCI works by comparing the current flowing in a hot wire with the current flowing in the neutral wire. In a properly functioning circuit, these currents should be equal. However, if a ground fault occurs, some of the current will flow through an unintended path to ground. This creates an imbalance between the hot and neutral wires. The GFCI detects this imbalance and trips the circuit. The GFCI uses a differential transformer to monitor the current in the hot and neutral wires. The differential transformer is a donut-shaped core with the hot and neutral wires wrapped around it. When the currents are equal, the magnetic fields created by the wires cancel each other out. However, if there is an imbalance, a magnetic field will be created in the core. This magnetic field induces a current in a sensing coil, which trips the circuit. GFCIs are designed to trip at a very low current level, typically 5 mA. This is much lower than the current that can cause serious injury or death. The tripping time is also very fast, typically less than 25 milliseconds. This quick response time is essential for preventing electric shock. Types of GFCIs. There are several different types of GFCIs available, including receptacle GFCIs, circuit breaker GFCIs, portable GFCIs. Receptacle GFCIs are the most common type of GFCI. They are installed in place of a standard electrical outlet and provide GFCI protection for that outlet. Receptacle GFCIs typically have a test button and a reset button. The test button is used to verify that the GFCI is functioning properly. The reset button is used to reset the GFCI after it has tripped. Circuit breaker GFCIs are installed in the electrical panel and provide GFCI protection for an entire circuit. Circuit breaker GFCIs are typically used for circuits that serve multiple outlets or appliances. Portable GFCIs are designed to be plugged into a standard electrical outlet. They provide GFCI protection for any devices that are plugged into the portable GFCI. Portable GFCIs are commonly used for temporary applications, such as construction sites or outdoor events. GFCI installation. Installing a GFCI is a relatively simple task, but it is important to follow the instructions carefully. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Before installing a GFCI, turn off the power to the circuit at the electrical panel. Use a voltage tester to verify that the power is off. Remove the existing electrical outlet and disconnect the wires. Connect the wires to the GFCI according to the instructions. Typically, the black wire, or hot wire, is connected to the terminal labeled line. The white wire, or neutral wire, is connected to the terminal labeled neutral. The green wire, or ground wire, is connected to the ground terminal. If you're installing a receptacle GFCI, you may also have the option to protect downstream outlets. To do this, connect the wires from the downstream outlets to the terminals labeled load. Once the wires are connected, carefully push the GFCI into the electrical box and screw it in place. Turn the power back on at the electrical panel and test the GFCI. GFCI testing. It is important to test GFCIs regularly to ensure that they are functioning properly. GFCI should be tested at least once a month. To test a GFCI, press the test button. The GFCI should trip and cut off the power to the outlet. If the GFCI does not trip, it is not functioning properly and should be replaced. To reset the GFCI, press the reset button. The power to the outlet should be restored. GFCI maintenance. GFCIs require very little maintenance. However, it is important to keep them clean and free of debris. Wipe the GFCI with a damp cloth to remove any dirt or dust. Do not use harsh chemicals or abrasive cleaners, as these can damage the GFCI. If a GFCI trips frequently, there may be a problem with the circuit or the appliances connected to it. In this case, it is best to consult with a qualified electrician. GFCI limitations. While GFCIs are effective at preventing electric shock, they do have some limitations. GFCIs do not protect against overloads or short circuits. Overloads occur when too much current is flowing through a circuit. Short circuits occur when there is a direct connection between the hot and neutral wires. Overloads and short circuits can damage electrical equipment and cause fires. To protect against overloads and short circuits, circuits should be protected by circuit breakers or fuses. GFCIs also do not protect against voltage surges. Voltage surges are sudden increases in voltage that can damage electronic equipment. To protect against voltage surges, electronic equipment should be plugged into surge protectors. GFCIs are an important safety device that can protect people from electrical shock. They should be installed in areas where there is a high risk of electric shock and tested regularly to ensure that they are functioning properly. Electrical safety tips. In addition to using GFCIs, there are several other electrical safety tips that you should follow. Firstly, never touch electrical wires or equipment with wet hands. Water is a good conductor of electricity, so touching electrical wires or equipment with wet hands can increase your risk of electric shock. Secondly, never overload electrical outlets or circuits. Overloading electrical outlets or circuits can cause the wires to overheat and start a fire. Thirdly, never use damaged electrical cords or appliances. Damaged electrical cords or appliances can expose you to live wires and increase your risk of electric shock. Fourthly, keep electrical cords away from water and heat. Water and heat can damage electrical cords and increase your risk of electric shock. Fifthly, use caution when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Sixthly, have your electrical system inspected regularly by a qualified electrician. A qualified electrician can identify potential hazards and ensure that your electrical system is safe. Electrical codes and standards. Electrical codes and standards are developed to ensure the safe installation and use of electrical equipment. These codes and standards are constantly evolving to keep pace with new technologies and to address emerging safety concerns. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and GFCI protection. In addition to the NEC, there are also a number of other electrical codes and standards that may be applicable in certain situations. These codes and standards may be developed by state or local governments or by industry organizations. It is important to be familiar with the electrical codes and standards that are applicable in your area. These codes and standards can help you to ensure that your electrical system is safe and compliant. Staying informed about changes to electrical codes and standards is crucial for electrical professionals and anyone working with electrical systems. These changes reflect advancements in technology, new safety concerns, and evolving best practices. Here are some ways to stay up to date on the latest changes. Firstly, subscribe to industry publications. Many industry publications, such as Electrical Contractor Magazine and EC&M Magazine, provide regular updates on changes to electrical codes and standards. Secondly, attend industry conferences and seminars. Industry conferences and seminars are a great way to learn about the latest changes to electrical codes and standards from experts in the field. Thirdly, take continuing education courses. Many organizations offer continuing education courses on electrical codes and standards. These courses can help you to stay up to date on the latest changes and to meet your continuing education requirements. Fourthly, join professional organizations. Professional organizations such as the International Association of Electrical Inspectors, or IE, provide members with access to the latest information on electrical codes and standards. Fifthly, consult with a qualified electrical inspector. A qualified electrical inspector can provide you with guidance on the electrical codes and standards that are applicable in your area. By staying informed about changes to electrical codes and standards, you can help to ensure that your electrical system is safe and compliant. Understanding the specifics of GFCI protection, including the number of receptacles allowed and the relevant codes, is critical for electrical safety. Always prioritize safety and consult with qualified professionals when in doubt.